9-8, Systems of Linear and Quadratic Equations. In Chapter 6, we learned how to solve systems of linear equations where our two equations intersected each other. And we had to solve by graphing, by elimination, and substitution. We're doing the same thing in this chapter. When we graph our parabola and we graph our line, we can have two solutions. We can graph and they can intersect at one solution, or when we graph they may not intersect at all and you'll have no solutions. When we go to graph, you're going to be using everything you've learned in this chapter, so that will be great to review it. Problem 12, y equals x squared plus 2x plus 5 is our parabola. When we go to graph the parabola, first thing you need to know is your axis of symmetry. X equals negative b over 2a is our equation for that. Again, my coefficient to the x squared is my a, the coefficient to the x is my b, and the constant's the c. So I use the 2 for b, 1 for a. Plug it into my formula, and I get my axis of symmetry at negative 1. So I put that on my graph. Then I substitute negative 1 into my equation. Negative 1 squared is 1. 2 times negative 1 is negative 2, plus 5, and I get 4. So then I plot my vertex, negative 1, 4. I also had to find other points because this graph is not factorable. I cannot take my quadratic equation and factor down to two binomials to find my x-intercepts. Since I can't do that, I now have to choose points on either side of my axis of symmetry. So I choose values for x of negative 3, negative 2, negative 1, 0, 1. Plug each one of those back into my equation. Negative 3 squared is 9. 2 times negative 3 is negative 6, plus 5 is 8. I have to plug all these values in negative 2, negative 1, 0, 1 in for x to get my other corresponding y's. So when I do that, negative 2 is 5, negative 1 is 4, 0 is 5, 1 is 8, and I plot all those points. Then I have to plot my line. It's in slope-intercept form. My y-intercept's 1, so I plot 0, 1. My slope is negative 2 over 1, so I go down 2 over 1, down 2 over 1, connect my dots, and I find that my intersection point is at negative 2, 5. I also have to solve by elimination. When we are solving by elimination, remember that we had to cancel one variable. My only variable that can cancel here is my y, because I have an x squared and a negative x. You always want to leave the x squared as a positive. In the book's example, they left it a negative x squared. It's just easier to always have a positive x squared. So if that is a negative x squared, you want to multiply it by negative 1. Since this isn't, I want to multiply through by negative 1 to my line. When I do that, I get negative y equals positive x minus 3. When I add my two equations together, I get 0 equals x squared plus x. 1 minus 3 is 2. Remember, an x squared and an x cannot be added together. Now I have a trinomial that I need to factor down to two binomials. So I always start with my constant. I'm looking for my factors of 2 that have a difference of 1. The only factors of 2 are 2 and 1. And they go into my binomial. Anytime this is negative, it's opposite signs. This is the sign of the largest. So positive 2, negative 1. Now that's set equal to 0, so I need to find the values of x, which are my x-intercepts. And I can either do that in my head, go what plus 2 gives me 0. That's negative 2. What minus 1 gives me 0? It's positive 1. Or I can set each one equal to 0 and solve algebraically. Once I have my x values, I'm still not done. I also have to find a y, because the point of intersection is always an x, y value. So I take negative 2, substitute it into either original equation. If I take negative 2 squared plus 1, I get 4 plus 1 is 5. And I get y equals 5. If that is difficult for you to do in your head, you can substitute it back into the equation and do it algebraically. Neither equation works. If I put it into my line, I'm subtracting my x value of negative 2 plus 3, so positive 2 plus 3 again is 5. You need to do that for both of them, so substitute your x into either equation. 1 squared is 1 plus 1 is 2. So always, once you get done, make sure you write your solution as a point, so it's negative 2, 5, and 1, 2. Our last way to solve in this section is by substitution. Again, you'll have a parabola and you'll have a line. When we solve by substitution, one of the two needs to be solved for a variable. In this case, my y equals 2x squared is already solved for a variable, so I'm going to write down my 3x minus, leave a spot for the y to go in, equals negative 2. So I have 3x minus, I leave my spot for my y equals negative 2, substitute in my 2x squared. Now I rewrite my equation. I always, again, want the positive x squared, so I'm going to subtract or get rid of that by adding 2x squared to both sides of the equation. Rewrite my equation again. I have 3x equals 2x squared minus 2. Again, those cannot be added because this is an x squared. That's not. I want the 3x also moved to the right, so I have a trinomial. So I subtract 3x from both sides to get 0 equals 2x squared minus 3x minus 2. Now I have a trinomial that I can factor. I'm going to use the AC method because I have a coefficient to my x squared. And when I use the AC method, I need to be looking at the A, which is 2, and my C, which is 2. You multiply them together, factors of 4 are what I'm looking for. Again, they're opposite signs. I have to come up with a 3, so I'm going to use negative 4 and 1. I break up the center term to negative 4x plus 1x, bring down my first term and my last term, my constant. Then I factor by grouping. So I look at the first two terms. 4 is divisible by 2, 2 is divisible by 2, there's an x in each one, so my greatest common factor is 2x. I factor it out. So 2x times x gives me 2x squared. 2x times negative 2 gives me negative 4. I do the same thing for my last two terms. Now in this one, there's nothing in common other than 1. I need to put that as a placeholder because you'll need it in your binomial. And then I write my x minus 2. These two binomials are in common. I factor it out, write my remainder of 2x plus 1 in my other binomial. So now that it's factored, and I can always double check, multiply through using FOIL, first 2x squared, positive 1x minus 4x would give me the negative 3x. Negative 2 times 1 is the negative 2. So when I again solve my binomials equal to 0, 2 minus 2 is 0. I always do this one in my head too. I know I have to have the 2 canceling, so I have to put a 2 in the denominator. And then I need the x plus 1 to cancel and be 0, so I'd use a negative 1. If that is hard for you to do in your head, again, just take 2x plus 1, set it equal to 0, subtract the 1 from both sides, so I get 2x equals 1, and divide by the 2. And now the last step is to substitute 2 back into the equation to find my y value. Since this isn't solved, since the first equation is not solved for y, I would substitute it in here. So 2 squared is 4 times 2 is 8. And then I'd take the negative 2 and substitute it back in. So negative 1/2 squared is positive 1/4 times a 2. 2/4 is 1/2. So I get my point of intersection at 2, 8, negative 1/2, positive 1/2. And those are the three ways to find our solutions of those systems.